welcome everybody to the knowledge series, Practical Bioinformatics and Data Management. And this knowledge series is organized by de.NBI ELIXIR Germany and GHGA. And on my first slides, I will shortly introduce both networks. So first of all, there's de.NBI and ELIXIR Germany. This is an academic research infrastructure since 2015. And I would say its basic focus is providing tools and services for the life science community, offering training courses, so about 80 per year, and offering compute resources in form of cloud computing. So the de.NBI Cloud is here, the corresponding hardware infrastructure. And I would say, in addition to this more academic focus things, there's also the idea to work together with industry in the industrial forum. And of course, we want to work not only with people in Germany, we also want to work together with bioinformaticians in Europe. Therefore, we are also part of the European Bioinformatics Network, ELIXIR. And you see here also the structure. We are composed of 24 partners. We are divided into so-called service centers. These are topic-based centers that always contain one important content here. So there's human bioinformatics, crop bioinformatics, microbial bioinformatics. We have topic-based service center like the RNA bioinformatics and proteomics service centers. We are also in workflows. We offer large databases in the biodata service center, and we are also doing systems biology and data management. And on the other hand, there's the German Human Genome-Phenome Archive, short GHGA. It is one of the NFDI initiatives, and the basic idea is to provide fair and controlled access to data while ensuring data security. So sensitive data is here one of the main aspects. And it is a federated network of 6 data hubs, as you see here on the map on the right side. So there are hubs in Heidelberg, Munich, Berlin, Dresden, and some more. And they also represent Germany on European level, like de.NBI. Here, they belong to the European Initiative GDA and FEGA. And I would say the basic mission of GHGA is making genome research easier and more sustainable. And here's also the QR code. And if you're interested in getting more information about GHGA, you can also go to the webpage. And the talk today will be offered by Kübra. Kübra works as a bioinformatician and scientific workflow developer at the DKFZ in Heidelberg, and these positions also belong to the GHGA network. She holds a doctorate in bioinformatics with a background in molecular biology and genetics from the METU, that's a university in Turkey, and she's I would say a Nextflow ambassador, and therefore today we will hear quite a lot of interesting new things, hopefully about Nextflow and Nextflow workflows. And yeah, stage is yours, Kübra.
Thank you very much. Hello, everyone, and thanks for all joining. As already mentioned, today I am going to be mostly talking about Nextflow and NF-Core, and we will be introducing the concept with reproducible and scalable workflows. And I will also do quite a bit introduction to understand how all this evolved, with starting from the traditional bioinformatic workflows, and then I would like to talk about the main pillars of standardization and reproducibility, like containers, versioning, and cloud registries. Then I will really try to complete the whole picture, how Nextflow or NF-Core or any workflow management system works. We, as bioinformaticians or bioinformatic analysts, tend to do the mistake of assuming we can reperform the analysis over and over again. However, most of the cases, I'm sure most of you know this, but it's not the case. What we built as analysis workflow, a method, always depend on some specific versions of software tools and a computational environment, which is primarily working on your own settings on a laptop, but it may not be the case for any other user, even for you for the next 6 months. All the parameters you used for the analysis, since you really change a lot under the defaults, I will say, it becomes really extinct and it is not obvious anymore. Though because the history changes a lot when you perform the analysis. So those assumptions are the building blocks of the hidden iceberg under the sea, and ignoring all the reproducibility tools makes your analysis non-reproducible or non-shareable at the end. In bioinformatics, the analysis usually compromise more than one step, one really after another. As the analysis gets more complex, you need to add more steps, which is happening sequentially, and all the tasks are adds on each other. Any software tool chain can be called as bioinformatic workflow, simply the one I show you in the figure. It can be in a simple bash script, in R, in Python, or any language. The main purpose of workflow is to automate the task to just one click. When you think about it, it's quite easy to write one click pipeline, and I'm sure everyone has one. To make those kind of workflows in the local infrastructures is easy. Yet, what really challenging arises when someone else needs to run the same analysis as you do. When you set up and install the tools for your pipeline, you don't really know which versions you are using. And of course, you know the main tools, but you don't know the dependencies. And most of the tools, like FastQC, when you install it, will depend on another tool, which is usually handled through package managers. And when they install each other, you are not sure about the versions anymore. And those kind of complex dependencies and the computational ecosystems tend to be fragile. If you try to install those tools in the figure, you are probably handling a lot of dependency errors. It is not really easy just to build the environment itself. And today I would like to mostly talk about how you can overcome those challenges to make your bioinformatic workflow really reusable. Let's remember our problem. We wanted to share our workflow with someone else, but the tools were problematic, so they couldn't really install the same versions. And what will happen? They cannot have the same results as you do. And what will be the very ideal solution? I would say packing your running environment to some system and send it with the bash script, the workflow you have. That will be very nice, right? Yeah, actually, containers does exactly this. One can generate the virtual environment, install all the necessary tools with the dependencies there, create the exact image with a screenshot, and send to others. And almost magically, anyone with this image can run the analysis using the pipeline with the same computational environment you know. This packing system is called as containerization and brings the standardization to tool portability. When I say portability, it means that you share and someone else takes and uses it. This system is particularly useful as it is completely isolated from your local environment. You just call this virtual environment when you need it. There are like mainly three concepts under containerization, but Bioconda, Conda, Mamba, Micro Mamba, and maybe some others, if exist, I don't know. They are different. They are called as package managers. They are not containers, but they are kind of helpers to create containers. So it is good to know how they work. With package managers, you define the exact software versions, and they solve the whole tree of dependencies and installs the tool to your computer efficiently. And when it comes to the container platforms, Docker is one of the well-known one. Just like in this cute figure, the logo, it packs the softwares to a whale and sends to the sea. And when you need these packages, magically it sends them and you just use it. Using the containers, the packages are kind of isolated from each other and from your local environment. And by this way, you share the environment with the dependencies, and at the end, it becomes really lightweight. Obtainer, which was formerly known as Singularity, is very, very similar to Docker. You can actually use the same image because they are interoperable. They can be interchanged, is a bit secure version of Docker, let's say, because it runs without root privileges, and it's usually mandatory for shared institutional clusters like HPC or supercomputers, but like ideally they work the same. If containerization is one cornerstone of the portability, versioning is the second, ensuring the full reproducibility. Versioning is creating an exact record, exact history of the code. There are three pillars of versioning. One is through Git tools, which are GitHub, GitLab, or yeah, there was something else I forgot. They are really very good to host the whole software projects like workflow files or any scripts, any tools you have. It is particularly useful because it tracks the whole development history, and which means that you can trace back in time and see what happened previously. But also, it is very nice tool when you need to develop collaboratively with some other people. Users can branch out from the main branches and then start to develop their own versions. And when they would like to do it, they can merge it back and continue from there. But all those changes are recorded. Second, versioning is also the case for Docker or Obtainer images. They are always tagged with the versions. And those versions are usually are the same as the software versions inside. And when you know the software version is tagged through the containers, one can just use it in the processes and know the exact versioning. There are container registries like databases where all those images are stored and shared publicly. I would like you to recommend to go through those. One of them is Quay.io, for example. And when you need to use an image of the tool, maybe don't start to develop it just immediately yourself, but check those container registries and use the existing ones because they are just there. Finally, all the references and databases are usually versioned, which is very important because most of the annotation tools changes a lot. The databases usually have very planned updates, and those may change your results. That's why most of the databases comes with the exact version, and when you need to use these references, you know which version you are using. The third reproducibility tool is the cloud registries. It's like Amazon Web Services, Google Cloud, and Azure are designed to share data, but also computational environment. They are almost, it's zero cost for publicly shared data set. I mean, someone else pays for it, but not you. And then when you need to really use these data sets, you don't need to manually download them. Some of the tools, you can just link them and use them almost automatically. This is very important because when you really need to share your workflow, you can put the link instead of writing, I use HG38, right? Even with the versions of the well-known human reference genomes, there are differences which may affect your analysis. Well, until now, we covered the major elements to standardize a bioinformatic pipeline to make it reproducible. And one last element to talk about is about scaling. Scaling meaning that you go beyond than your local environment. A user develops the tool at local, which is practical, but technically challenging at the same time, because our resources are very limited in the local. In the HPC clusters, where it's controlled through the institutional clusters, can provide you more resources. They are very well controlled. They also design the whole file structuring, but also help you to execute the analysis. It is nice to execute more heavy jobs. There is also cloud computing, which is more elastic, like using the AWS, Google Cloud, or Azure. The resource there is very scalable. It's almost endless, limitless. When you set up your workflow environment to run through the cloud, you can optimize your resources as much as you do, and almost instantly ask the environment, use it and pay, and then repeat as much as you need. If we conclude about the whole concept, the workflow, the classical workflows becomes workflow management systems if it is fully reproducible, portable, and scalable. Some examples are SnakeMake, Galaxy, Pegasus, and Nextflow. They are all of them are open source and freely usable. The main advantage of using them is really to enabling the containers. Containers are very important because it's the main element for portability. When you link your softwares to the containers, you can easily share them. In this workflow settings, usually reference files are connected to the cloud registries by just links, and user can download and incur them while running the environment itself, while running the pipeline itself. One of the very nice elements of this workflow management systems is the automatic checkpoints. So when you run your analysis step by step, one by one, there's always a possibility of errors, right? It can just fail in any step. And in the old setting, the usual pipelines, you cannot start from the where you left. This is mainly because it is hardly coded, let's say. You cannot really one step just rewrite. It doesn't happen. You really need to rewrite the pipeline if you want to start from the middle. But in the automated system, they cache through this whole previous runs and enables you to caching those intermediate results, which is saving the recalculations, which also saves significant time and compute resources. This is, I think, a big advantage over the management systems. And after all, when the execution is finished, the managers provide the option to generate execution reports, which is the detailed information about the run. Then you know which files are used, which versions are used, and how much memory, how much CPU consumption required, and basically it is the full history of your analysis. Finally, with the workflow managers, this system is usually suitable to do more than one sample analysis simultaneously, which is about parallelization and always design dependent. But if you really design your pipeline properly, you will enable running like 10 samples simultaneously and get the results. And finally, they share the projects through GitHub repositories or GitLab repositories, which allows you to collaborate, share, and get feedbacks. Yeah, about Nextflow. I will be also talking about Nextflow right now. It is a workflow management system designed to make the data-intensive computational analysis highly scalable and completely reproducible. It allows researchers to write their analysis logic once and execute it almost seamlessly across different computing environments using the software containers. The Nextflow script can consist of many simple processes composed into pipelines, and each process can be using any tool or any script like R, Python, Bash, or C, whatever the tool has it. And after all, Nextflow does the job to coordinate the execution of tasks, orchestrating the data flow for you. You can define the dependencies through either Docker, Singularity, now it's Container, but Conda, or I think they support more, but now I cannot recall. And the runtime integrates with the execution platforms like HPC schedulers, LSF, Slurm, or the cloud providers that I mentioned before. And finally, you can just share your pipeline using GitHub. Therefore, the Nextflow is supporting reproducibility as the integration with code management tools with version releases. It is portable, supporting containers and package managers like Bioconda, and it works with many computer environments. It is highly scalable, where one can perform multiple samples at the same time. I don't want to go details of the language itself, but I think how it runs, to know how to run is a bit important. That's why I just would like to mention about the simple processes and the whole logic of channels. Nextflow uses the channel system to read the data, the files, as well as the samples as an input, and it packs all those samples into a tube-like system with the channel and sends through the processes. Here, for example, it's FastQ. It receives all the samples one by one, process them separately, and when they are finished, it packs them all again to the output channels and sends to the other process. In this case, it is multi-QC, and the same process is repeated again. Here, what is good to know is these samples, they go one by one, but it doesn't really need to be one after each other. It can be also simultaneous. One can perform those three process at the same time. This is the main process, and the main process basically defines the script and the environment to run on, which can be also like local system, the cluster or cloud compute. What is important is it's either way using the containers, so it doesn't matter for the Nextflow. One important aspect behind Nextflow is really NF Core, and I would like to talk about a little bit of NF Core more, let's say. It is mostly because I believe it is really important because it's mostly community developed tool set, and it really makes the life easier knowing the NF Core and the freely shared tools. Nextflow, NFCore is the community behind Nextflow. It is an effort to develop pipelines using Nextflow and share with everyone freely. So everyone can contribute NFCore openly and transparently. And as GHGA, we really value this mindset and the approach, and we also try to contribute to the efforts. I would like to mention about the NF Core components. And one of the main elements is the NF Core written pipelines. It is a huge repository, really, involving then 1,000 people. I think the community started mainly to share pipelines, but it is right now more than that. Right now in the repository, I think there is even more than 552 pipelines. These are some of the common pipelines, let's say. I think everyone knows SIREC, which is very popular analysis pipeline for germline or somatic variant coding analysis. Also, RNA-seq is very, very popular for RNA-seq analysis. I think why it is quite popular is also because it is very well written and highly documented. If you go to the Nextflow website to any pipeline, you will expect a huge documentation where there is a very well information about the tool used and also about the pipeline, the usage parameters, outputs, and all the releases. This is from the results section. I would like to highlight it because whenever an NF-Core pipeline is producing a release, it also executes a full-size sample analysis execution, where you can also find the results through ABS results section, where you can actually see what an execution result looks like. And before you perform the analysis, you know what to expect from the pipeline itself. Even though all this documentation exists, it can be misleading. Here is the section you really know what to expect. Running the pipelines is very easy. You just need to install Nextflow and also the container you would like to use, let's say Docker for your local is useful, you can install it, and then that's it. You don't need to download the pipeline and stuff. You can just run it, specifying the version with the R, and that's really it. You need to write the sample sheet CSV with the links to your samples in this case, and you will have the analysis. And since it is tagged with the version, there is no way to expect something else when someone else uses the same pipeline. Another component from NF Core is the modules. Modules are the atomic processes that I showed earlier with the, for example, FASTQ, MultiQC. They are all modules. In the NF Core repository, there is probably now more than 2,000 modules and more than 123 sub-workflows. It's really huge. I would recommend you to go and observe it. Whatever tool you may use, you can already find it. What is really nice is you can also install it to your own pipeline, just a plugin, and use it. For me, it is almost like a puzzling system to install the tools from there and just use it. This is an example, one of the modules. As pipelines, they also have extensive documentation with the parameters, input types, and output types. You also know who is maintaining it, and if you go to Slack, you can just directly ask questions to them. The modules are highly standardized. This is an example. I just wanted to put for you to show the main element. For example, here one can define the memory and the containers, the content link with the environment list, the inputs, outputs, the version tag, the main script here, and the stub script. Stub script is very important because it makes debugging quite easy. But I will come to the testing later anyways. Yeah, it's here. One of the core elements of NF Core is really testing. Testing is quite important, especially if you're working with a huge list of contributions, right? I told you before, it's like 1,000 people who is contributing the same repository simultaneously. You really need to put some standards if you want to maintain those properly. And testing establishes and protects the standards, let's say. One of the core elements is the NF test. NF test is a plugin, like an external tool, where you can check if your module or pipeline is working as expected. It is like unit test with a different mindset. One can write the small test inside NF test and create the execution, and it will produce the output files. And each output files will get a snapshot. These snapshots are numbers, and you expect the same when someone else execute the same test. It's a way of checking if something is changed, if the changes affected something. So it's a good way of maintenance. There is always GitHub reviews in the repositories, and without the PR approval, no one can merge anything. So it is highly important because even after the NF tests, something may go wrong, right? And the third element is the CI testing. CI testing involves some other checks as well, plus to NF test, also like linting. It is automatically checked if the syntax is correct, if the template is correct, if everything is aligned properly, you will have the checks completed. And if you have your approve, you can go ahead and merge. Another component of NF Core is the tooling system. NF Core is not only pipelines or modules, but it is also really a software behind it. Keeping all those standards is not easy. You really need to have a helper, like helper tools, let's say. They have like many components of the tools. One of the useful one is creating the templates. Here, for example, I printed out how to create the template for the modules. So it is interactive. When you type in NF Core module create, it will start to ask you like the name of the tool, who is going to maintain it, if it already has a bioconda image, like everything. After you answer the questions, you will have the template and you can just start working on it. There are also tools to install, update, remove, or patch the modules or pipelines, and also for linting to check everything is correctly created. I mentioned about template, which is actually the schema. And schema is for the modules, it's just like that. What I am talking about is the pre-described rule set. Here, for example, it is the example module I created. It comes with the sentences of to-dos, and you just need to go through all the to-dos and resolve them one by one. It will show you to resolve all those sentences properly, and then you will have your example tool. Another component is linting. Linting is really the checking if everything goes as expected. So if you created your tool and resolved all those to-dos properly, it will be expected to apply the standards for the template, right? But let's say you made a mistake. You have a trailing white space, which is very common. And then you will have this complaint from the linting telling you where you did the mistake, and you go ahead and you resolve your error and lint again, and this errors hopefully will be gone. So it is basically for you to highlight where you are going out of the standardization, and when you correct it, it will be ready for the merging. There are also many plugins under the NF Core and Nextflow. These are kind of different than NF Core tooling because this is really the result of the NF Core community. So previously, when I think Nextflow and NF Core was in the initial stages, it was not like a standardized as now. Everyone was creating their own functions inside the pipelines. And it appears that those functionalities can be also important for someone else. When they realize it, they created this smaller software groups and started to share under the plugins. Those plugins, you can also insert your analysis pipeline and use their function simultaneously. I just wanted to show 3 of them as an example. Here, NF schema is where that was known as validator. It validates the input schema automatically. It used to be not the case. When you write the pipeline, the input checks were not automatic, but user needed to write a code like in R or Python to check if the inputs are as expected. But now it is through the JSON schema, and you need to fulfill the schema, and it is automatically checked, which is very useful. NF Pro is another plugin. It creates provenance reports, and in GHGA, for example, we use it to ensure the fair standards. And one of the cool one is the carbon dioxide footprint predictor. I find it really cool because this is based on the calculation towards carbon footprint, which was already exist, but they try to really incorporate it through the Nextflow pipelines to understand how much carbon footprint we create using those pipelines, which is very responsible act. Yeah, now I would like to summarize the talk by mentioning how Nextflow and NF Core is being used under GHGA and how we cooperate with each other. And in the workflow workstream in GHGA, we aim to standardize workflows to allow unified data processing, creating ready-to-use harmonized NGS data resource for bioinformatics research community. So we develop pipelines, we generate standardized configurations, and allow the user to benchmark it with other tools. And why we use NF Core and what does it bring us? First of all, it's really about portability. Portability across platforms is highly important for us because GHGA is a national platform, more than 6 institutes, which has different standards and different computational needs. And when you have such a system, you really need to have you need to ensure the portability across different platforms. And of course, has a setting I wanted to just mention. It's another repository about configs, and they share all the configuration settings across different platforms. So let's say you are using Slurm, you can go and check the Slurm profiles and maybe replicate in your setting. I mean, being inside a national platform requires parallelization and optimization for sure, because the number of genomic data set we deal with is huge, and it's a big size of data. That is why we want to ensure the scalability across different institutes. Of course, reproducibility is important, and as GHGA, we are applying fair standards, and we want not only now, but also in the future, users to be able to redo the analysis we do. Well, we also want the pipelines to be flexible because bioinformatics is something changes a lot. There are like new tools every day, and keeping this setting ongoing requires high flexibility. And as you see in the Nextflow pipelines, you can really plug in and plug out the tools quite easily. And finally, stable releases are highly important. Versioning of the pipelines are standard. Yeah, testing is obviously the need for automation, and we would like to keep the standards. And provenance is another tool for us. Yeah, finally, community support is everything. And NF Core has a big user set, and I really recommend you to go to the Slack chat if you have any questions about Nextflow or NF Core. They are quite helpful, and I'm sure you will find someone to chat with you for your particular error. But if you are interested, we have a set of trainings under GHGA. We also have the events, sometimes webinars, sometimes also like big workshops. And this is the YouTube archive. And finally, Nextflow has a good resource for trainings. It is quite big, and they target more than one level for like beginners, intermediate users, or advanced users. You can, like, anyways, the reason you can just go and check. And this is the Workflow workstream team, and I would like to thank everyone for listening, and I can take the questions.
Yeah, again, thank you, Kübra, for the nice talk today. I think we learned quite a lot of new things about Nextflow and NF Core, and I hope that yeah, more people will now use NF Core to do their analysis. And yeah, I think then we are
Thank you.
almost done. Yeah, thank you for the interesting questions and for the attention. And yeah, hopefully I see you at the next webinar of de.NBI GHGA. So yeah, have a nice afternoon and see you.